Okay, we're going to define a mathematical idea called continuity. Okay, so continuity is, intuitively, if you think of things, think of what the word continuous means. It kind of means without a break, right? If you're running continuously, you're running and you're not stopping. If somebody is yelling continuously, it means they're yelling and they're not stopping. There's no break. Okay, so that notion, there's a strict mathematical definition for that we're going to see as it relates to functions. So I'm going to write down a definition. A function y equals f of x is continuous at a point in its domain. Okay, so at an x value, if, actually I should say at a point C of its domain, if the limit as x goes to C equals f of C. Okay, so remember what we talked about with limits. Limits refer to the idea that as you approach particular x values, you also approach particular y values, right? And so the answer to the question, the limit of f of x as x approaches C, is whatever that y value is that you're approaching. And if that happens to be equal to the output when you input C, then your function is continuous. So at this point, I think an example would be easier to follow. Okay, so I'm going to draw a graph that kind of gets at a lot of the key ideas you want to know about continuity. So I'm trying to make your graph identical to mine. Okay, so let's call this y value 1. Let's say this y value is 2. Let's say this y value is 1/2. So I need this here to be the point 7 1/2. Okay, that's what I'm intending. Let's call this, let's say this has a variable asymptote of x equals 6. Let's say that's an x value of 3. Let's call that 1. And let's call this here 4. Okay, so there's my graph. So we're going to ask a few questions about continuity. Is f of x continuous at, and I'll ask a few x values here, at x equals 2. Is f of x continuous at x equals 2? Actually, what I mean is x equals 1. Sorry, x equals 1. Is f of x continuous at x equals 1? Well, according to the definition, I have to look at what the limit is as x goes to 1. So the limit as x goes to 1 of x. Okay, if you refer to the last video on limits, you'll know that this answer is 3. Okay, as x approaches 1 from both sides, the y value you're approaching is 3. Okay, and what is the output when I input 1? Well, that's equal to 3, right? So the answer is yes, since the limit as x goes to 1 equals f of 1. in which 3 equals 3. So the answer is f of x continuous at x equals 1? The answer to that question is yes. And the reason is because the limit as x goes to 1 of f of x equals f of 1. How about at x equals 3? Well, the limit as x goes to 3 of f of x. So this is where you want to think, what am I approaching? Okay, as I approach from the left and the right side of 3, what y value am I approaching? The y value I'm approaching is 2. Okay, so remember, limits don't care about what's actually at that point. They care about what you're approaching. Now, what is f of 3? Okay, what is the output when you input 3? Well, f of 3 is right here. F of 3 is 4. Now, are those the same? Is 2 equal to 4? No. So the answer is no, since the limit as x goes to 3 of f of x does not equal f of 3. Okay, and again, 2 does not equal 4. What we say is, in other words, there's a discontinuity at x equals 3. Let's do just a couple more. How about at x equals 6? Is f of x continuous at x equals 6? Well, this one is actually pretty easy, okay, because the limit as x goes to 6, when you approach 6 from both sides, it looks like you're heading to positive infinity. But what is f of 6? Well, f of 6 does not exist, because there's a vertical asymptote at 6. There's no output value for 6. So this has no possible way of being continuous. So the answer is no, and I'm not going to write down the reason again, because because I wrote it twice above. Okay, after I wrote gave the explanation above, I think you get the idea. But to answer the question, it's not continuous at x equals 6. So we'd say there's a discontinuity at x equals 6. I'll write that. Discontinuity at x equals 6. And let's lastly consider at x equals 7. Well, what is the limit as x approaches 7? Well, the limit as x approaches 7 does not exist. Okay, now this is important. The reason the limit as x approaches 7 does not exist is because if you approach 7 from the right, your answer is, I guess I didn't put 1 up here, the answer is 5. And as you approach 7 from the left, the answer is 1/2. Those are not the same. The left and the right hand limits are not the same. So the limit as you approach 7 in general does not exist. Okay, but what is f of 7? Well, f of 7 is, if you go up to the graph, f of 7 is 5. Does dne equal 5? No, it doesn't. Okay, so the answer to this question, is f of x continuous at x equals 7? The answer is no. And again, that means there's a discontinuity at x equals 7. Now, one thing to keep in mind, it's actually pretty easy. I mean, if the question is just a yes or no, is f of x continuous at x equals 1, at x equals 3, at x equals 6, at x equals 7? Rule of thumb is, if you can trace the graph, or anywhere you take, if you trace the graph from left to right, any point at which you have to lift your pencil up and then put it back down, at any x value for which you have to do that, if there's any x value for which you have to do that, that means there's a discontinuity there. So any place you have to lift your pencil up to continue tracing the graph, there's a discontinuity there. Okay, but what's nice here is I already gave you a really precise mathematical definition that we will see again later on in the year. So there's discontinuity, and again, the type of questions you'll be asked are, find the discontinuities. Remember, those are always x values, And the key definition here is right in this box. That'll always lead you to the right answer.